QSO Today, episode 477, Steve Stroh N8GNJ. This episode of QSO Today is listener-sponsored. Only you can keep the QSO Today podcast coming to you every weekend since 2014. Please become a listener sponsor monthly or annually by clicking on the sponsor banner on the show notes page or at the top of the QSOtoday.com webpage. Sadly, there were no new listener sponsors or donations this week. Welcome to the QSO Today podcast. I'm Eric Guth, amateur call sign 4Z1UG, where I demonstrate the diversity and relevance of the amateur radio hobby and its impact on society by interviewing ham radio operators, many of whom played vital roles in shaping our technology through the amateur radio hobby. And while many people might say, ham radio, do people still do that? This podcast demonstrates through in-depth interviews just how amazing, diverse, and dynamic the amateur radio hobby continues to be. I'm nurturing a cold this week along with everyone else in Israel's home front. Married to a school teacher, I get whatever she brings home at least once a year. I have had a large number of great QSO Today interviews and want to thank all of you who recommend or volunteer to be interviewed. Everyone seems to have a fascinating story and are doing ham radio projects that come under our expanding ham radio umbrella. These interviews will be coming up soon. Stand by. Steve Stroh N8GNJ has always enjoyed the confluence of computers, data communications, and amateur radio from the earliest days of AX.25 packet radio to the current AREDN and SDR software-defined radios. Steve uses his newsletter on Substack to communicate the amazing amateur radio technology developments in data communications that does not get covered in the standard ham radio journals. N8GNJ shares his experience and interesting stories in this QSO Today. N8GNJ, this is Eric, 4Z1UG. Are you there, Steve?
I am, Eric. Pleased to meet you. 4Z1UG, N8GNJ.
Steve, it's such a pleasure to meet you. As I said earlier to you, it was K. Savitz, K6KJN, who suggested that I talk to you. You're on the cutting edge of the amateur radio frontier, and I like hearing about the cutting edge of the amateur radio frontier. But before we get started, let's start at the very beginning of your ham radio story, at the early edges of your ham radio frontier, and find out how it started for you.
I discovered amateur radio from a stack of old 73 magazines that had been donated to my city library in a little town called Port Clinton, Ohio, where I grew up. And I was an electronics fan, not even a geek. I didn't have any skills, but I was curious. And I discovered this whole other world, that where these people were having fantastic fun, and reading Wayne's editorials and the conversational tone of the articles. It was so approachable, but very limited resources in this small town, so I didn't do anything about it until I got into high school. I actually took the test when I was 17 at the FCC field office in Detroit, and I passed the test, but this would have been the novice test, but they didn't pass me because I had flipped. It was coming just a little too fast for me, so I flipped the paper over and wrote the dots and the dashes. Then interpreted it, answered enough of the questions correctly. But when the examiner flipped the paper over and saw the dots and dashes, said, "Well, you didn't meet the spirit of the exercise, so I'm not going to give you your license."
That's pretty harsh.
So it took another seven years to get my novice license.
But can we go back a little bit to Port Clinton? It sounds to me, if it's Port Clinton, port means you're on the water somewhere?
The southern shore of Lake Erie between Toledo and Sandusky.
And you had this interest in electronics, or you saw 73 magazine. Did you see any of the other magazines of that period, like Popular Electronics?
So I was a subscriber to Popular Electronics with my paper route money.
Me too.
And I remember that totally magical moment sometime in December 1974 when I went out to the mailbox and standing ankle deep in slush and pulled out Popular Electronics, the January 1975 issue, and saw the Altair on the cover. that was a totally magical moment. So yeah, I was kind of self-educating, but I didn't know enough of the basics. So I was, just following along and, doing a few experiments and things, but it was enough to excite me. And my post-high school career went to an electronics trade school called, what was then grandly called Ohio Institute of Technology, now called DeVry.
They're all over the country now, right?
They are, yeah.
Did that Altair computer, and I remember that as well, as I recall, didn't that have the blue and red flip switches across the front of it?
Yeah. I didn't learn to program on an Altair, but its close cousin, the MSI, when I got to DeVry. And the guy that taught the microcomputer programming class, the assembly language programming class, was a guy named David L. Heiserman, who was famous for writing a book called Build Your Own Working Robot. He had written this time-sharing system to timeshare a chunk of, I think it was 4K of memory across 8 dumb terminals. It was just total magic when I understood the relationship between transistors and ICs and software. He made that connection, and I've just been fascinated with computers ever since.
When you did your work at the Ohio Institute, now DeVry, was it in computers?
It was essentially electronics trade school. It was a general purpose electronics education on maintaining, building, understanding, troubleshooting, that sort of thing. There was even one course. This was so long ago. There was a course in TV repair and tubes.
And at the time, that was a very respectable occupation, as I recall.
It made me instantly employable, which was a real benefit, in the early 1980s.
When you graduated, where did you go? What did you do with that?
I took a job that very, very few people have ever heard of. It's called doodlebugging, which is doing oil exploration. And in my case, I went to the Gulf of Mexico and rowed oil exploration ships. These are the folks that scout out potential locations to do an exploratory well. And we would do that by setting off a small explosion in the water. It was self-contained. It was a big rubber boot with a propane charge and a spark, and it would go boom, boom. But it was a very consistent acoustic signature. It would go down into the seabed and reflect back up off the layers. And then we trailed a 2-mile string of hydrophones, and we would record that data. It went back to Houston. It got processed by their Cray supercomputer to do prospecting, to tell the oil companies, yes, this is the likely spot. This is not. Basically, the best we could do was vague suggestions, but, it kept me employed.
That sounds like an amazing opportunity for a young man. Explosives, electronics, boats at sea. It would check all of my boxes.
It was fun. The tail end of my experience with that company was doing the same thing in the Bering Sea in Alaska. And there I was at sea for 30 days at a time, brief port call, another 30 days. Then they sent you home for 30 days. And wherever in the United States you called home. So they got you there. And I would lug my Radio Shack color computer in the biggest Zero case I was able to find. I packed up my 2 big floppy drives, my color computer, and fortunately the ship had enough spare monitors that I didn't have to haul that around. So that was my computing system at the time.
With the color computer, when you were off duty, what did you do with the color computer? Were you writing programs?
I never quite got into programming, but I loved the best application I used on the color computer was a word processor, a real honest-to-God word processor. I think it was called Tellwriter 64. I would write very long, rambling letters to my family and my fiance, my long-suffering fiance, now wife, Tina. And that was one of the hardest parts about it, was that we had gotten engaged and I had to go back to Alaska, and she didn't, and she was finishing her nursing degree. So, it worked out financially or, career-wise, but it was hard on the relationship.
My guess is that you're in your 50s or 60s.
60s.
and that absence makes the heart grow fonder. I can't think of how many marriages I know that are long-standing that began with a correspondence relationship, because you meet them and then you start writing to them, but you're thousands of miles away, and for some reason it turns out to be a long-time thing.
The most interesting thing about that is that, to me, is that I wake up every morning with her next to me, and I never take that for granted, because for years we didn't have that luxury.
Because of the work that you were doing.
Right. And just the physical separation.
Now, you say that you got your license 8 years later in your mid-20s. How did that go, and what license did you get?
I'd come back to the States and settled, and Tina got her nursing degree in Cleveland, Ohio, so we decided to settle in Cleveland because she could leverage it immediately. And I found a job in Elyria, Ohio, working for Bendix Westinghouse Air Brakes, and they were creating what at the time was the first electronically controlled, well, you've heard of steer by wire or fly by wire. This was brake by wire. They were trying to develop a new system because of these very long road trains that were becoming used in places like Australia, and trying to signal the rear brakes to shut down pneumatically was not a good strategy. So that was my first job, and I came across one of my, you ask about Elmers in your questionnaire, and one of my primary Elmers was a guy named Ken Coy in KTV, who I worked with. And Ken directed me to a local club, and I went through the licensed classes and got my novice license through them with the totally forgettable call of Kilo Alpha 8 Whiskey Charlie Lima, K8WCL. And I hated that call. And the moment, it's just, I worked hard to get my technician, and then I got to do a 1x3 call, which is not my current one, N8GNJ.
That was the call that you got, was the N8GNJ.
Right. Yeah, that was my tech call.
Why is GNJ? Why did you choose that?
I didn't. That wasn't a vanity call. That was a random assignment.
Because you could get an N call with 3 letters.
Right, and it wasn't KA8WCL. So.
My first call sign was WN6VHV. As a novice, I thought it was a terrible call on CW. I was happy to see it go.
Amen.
Okay, so you got your technician license first. Have you upgraded?
I'm a general.
It seems to me, at least when I'm looking you up, I'm looking at your QRZ and I'm looking at your website and stuff, that you have an affinity for packet radio. Were you involved in early packet radio when you first got your technician?
It was the primary reason I got my amateur radio license, because talking just has never excited me. But the ability to combine packet or computers and networking and radio, it's all in there in amateur radio, packet radio. So yeah, that was the very first, my first love, first and primary love. I don't say packet radio so much anymore, because that locks a lot of people into AX.25, 1200 baud, all that stuff. And the technology is going considerably beyond packet radio. I'm into data communications over amateur radio. That's my primary interest, with secondary interest in satellites and things.
I don't want to get too far ahead of us yet. So I do want to know, when you were doing AX25, I actually saw something in your newsletter that you were actually looking for AX25 TNCs.
I have a project that we can talk about, but no, I was looking for data radios, inexpensive data radios, to be able to essentially set up a test bed, many different TNCs and other devices like what are called, colloquially called sound card modems, sound card, and other and more modern TNCs. And I want to be able to let them interoperate, and then, it's like software developers, be able to shell into the system and do their testing. Because a lot of these guys who are developing software, they don't have access to an active packet radio network, but they're curious. So I figured out that I think, needed by the developer of Direwolf, the Direwolf software TNC. He doesn't have a very active packet network where he is, but he's doing some amazing work. So I figured, I've got a big shop. I've got lots of radios. They're not doing anything. They can happily talk to each other over dummy loads inside my metal walled shop. So yeah, that's a project that's very much in the early stages.
You'll be using AX25, or you'll be using a whole bunch of different modes?
Whole bunch of different modes.
Parenthetically, I actually did a X25 project for a power company in Colorado at one point, and I had hundreds of these units that I had to test. What I actually ended up doing was I actually created an audio mixer out of a bunch of 2 to 4 wire converters at the Westcoms. I had racks of Westcom converters. I think you could probably do it a lot cheaper now than that. But essentially, I connected all these modems to this big audio mixer, and that was my network to be able to simulate hundreds of simultaneous X.25 communication sessions at the same time. I'm just throwing that out as an idea.
I understand the reasoning for doing that because you had consistent radios. One of the biggest problems right now in amateur radio data communications is the very, very widely varying characteristics of all these different radios. So there's a lot of misconceptions about, what's possible. And I want to be able to show that, like, for example, a lot of people think that 9,600 bits per second is essentially, not doable, but it is if you have the right radio. And now that we have these technologies, especially forward error correction and just better modems.
Right. And processing power behind those modems too.
Well, the processor is the modem, which blows me away. 2 or 3 passive components, and then you've got a processor, and it's basically just doing brute force sampling and generation. And you can throw this $4 processor that is in the hundreds of megahertz at the problem, and it's easily doable.
Like an ESP32 or something like that, right?
Right, exactly. It's just astonishing what you can accomplish with these very inexpensive processors. And one of the articles that I just did was a discussion that started on Facebook, and I said, if Kenwood is going to restart the TM-D710A, they'd be idiots to just try to use the same modem chip. When you can throw a processor at it and do the whole job in software so much better.
Well, you got me thinking, and so I was reading this article today when I was kind of researching you before our interview, and I'm thinking, well, I did want to add to your conversation that I would try a Bofang 888 board, but I've got one stripped down to its shorts, and I thought if I put in, a bunch of square waves to actually see what that looks like at the end in another device and see how much speed and recovery before I start sending data, but actually see if the waveform still looks like a square wave at the other end, depending upon the bit rate. So I thought, well, maybe I'll try that and send you my results, because it seems to me those things are so cheap. What I ended up doing with the power company system is, at the time, they were data modules that Rytron, I think, was making.
Oh, yeah.
I think they were VHF. And you know what? Those things, if I ski down the hill in Keystone, my system after 30 years is still on the side of the mountain there running those Rytron modules. So I thought, trying the little 888 for $12 or $10, whatever it is now, it seems like that would be a pretty interesting idea to make a project, a data project.
My basic idea is to prove out get a stable reference implementation. Like for example, the Kenwood D710 is probably the best 9600 baud system there is, because Kenwood matched the modem and the radio together perfectly. So, that's a really good reference implementation. And then, I have 2 710s that'll be in the system, and they'll communicate with each other, and then just gradually, test various modems against that reference implementation to see how well they do. Because all the testing that I see done, is all done in a vacuum. They test an individual unit, but they don't test interoperability. And that's the big thing that we need to get better at, is interoperability. Because 9600 is a finicky beast.
If you're using DMR, for example, what's the baud rate of DMR?
It's 4800.
For the whole thing, for the whole package?
Yeah, System Fusion is 9600.
System Fusion is Yaesu product.
Right. That is definitely 96. I'm going to have to double check on DMR.
You know, there's a lot of radios on eBay, digital radios on eBay. Tate, Kenwood, Yaesu, Motorola.
The outtake from a query I put out on my newsletter was that the Tates are the best pure data radio, but the Kenwood commercial radios are pretty good and pretty easily hacked. In fact, one of my readers just is sending me 8 radios that he acquired in a great big lot, and he says, "You pay shipping, and I'll get them to you." So that's going to be the genesis of the lab. Well, that and the 710s and a few other radios.
I'm actually thinking more about off-grid communication, local communication, data communication. My neighborhood is going through a rough time right now, and there's a possibility that we could lose power, we could lose cellular telephone service that we think works all the time. The majority of my neighbors here think that their cell phones would never not work. I'm becoming very skeptical in terms of that this is a robust infrastructure. I know it's not. So your project is very interesting to me. And even going back to something like 2400 baud packet, to be able to move any kind of traffic, data traffic, is actually very interesting and important, I think.
Mm-hmm.
So let's go on from there. You have moved well beyond AX25. What is the packet radio service of choice that you seem to be spending more time in right now?
There's a totally proprietary system called VARA, developed by a ham in Spain. And he was able to meld a whole bunch of techniques. And from what I can tell, he basically took a whole bunch of libraries that were available and kind of mashed them all together into a very usable system called VARA. And the one that really gets me interested is called VARA FM, VARA FM. And he can do, under the most ideal conditions, 25 kilobits per second in a standard FM voice channel, which, we could never, we never got away with that in packet radio. And he layers a whole bunch of techniques. He does channel sounding. He does OFDM. He does negotiation between the two endpoints. Just a whole layer of techniques. I dissected it in a series of articles in Zero Retries, and I just came away totally astonished at how much he had accomplished. And it runs on a Windows PC with a standard. Well, you got to have a fairly high quality audio interface. There's a very good series called the Digital Radio Adapter from Masters Communication that's very high fidelity and gives you the best performance for the system. And of course, you have to have a radio that lets you have access to flat audio, no preemphasis or de-emphasis, the 9600 connection. So you have a good audio interface, a Windows PC, and a radio with flat audio. You can do 25 kilobits per second all day long, back and forth.
That's a speed that you could actually send a spreadsheet or a document.
Absolutely. Well, it's becoming widely adopted by a lot of MCOM organizations because it just blows conventional 1200 bits per second packet radio out of the water. Oh, and the other thing is it's very reliable because one of the techniques he uses forward error correction, back before we actually had that available as a add-on for packet radio. So that's the most interesting thing going on in VHF and UHF. But we're also finally getting to the point of having software-defined radios for VHF and UHF to implement all kinds of interesting modes. And then I'm quickly getting into the microwave stuff with a system called AREDN, Amateur Radio Emergency Data Network. Basically, that's firmware for Wi-Fi and wireless ISP devices that make for very easy and ham-friendly mesh networking over microwaves. And they're building entire networks out of this technology, and especially in California, which is getting a fair amount of use when, the grid shuts down and you lose all your communications.
And now this mid-show break. The future of podcasting and the QSO Today podcast is listener sponsorship. It keeps us lean and focused on providing you the best ham radio interviews since 2014. You can keep the QSO Today podcast commercial and sponsor-free by becoming a listener sponsor yourself. For $10 a month or save 20% at $100 per year, you can become a listener sponsor. I am now recording the QSO Today podcast as video interviews that are available only as a benefit to listener sponsors through our QSO Today community website. As I develop the sponsorship tier, I will add bonus content for listener sponsors. Listener sponsors, not donors, are automatically members of the new QSO Today Academy. I am building the Academy website to include access to our Sequel.io networking lounges all of the time and Academy resources including over 400 previous Expo presentations with Q&A and additional helpful ham radio educational resources. The benefit of listener sponsorship as an alternative to commercial sponsorship is that commercial sponsors influence the content and comments in the podcast. Listener sponsorship allows a greater degree of freedom to discuss any ham radio subject without commercial consequence. I have eliminated all commercials in the QSO Today podcast from episode 445, with the exception of the Ham Radio Workbench podcast, as I think that this is a serious asset to a well-rounded ham radio education. I am not using Buy Me a Coffee or Patreon, but my own system for managing the community that could form out of the podcast. I direct you to the sponsorship section of the show notes pages beginning with the episode 444, where I list all of the contributors to the podcast since 2014, including sponsors, donors, and hams who have paid for transcriptions. If sponsorship is not your interest, then you can make any size donation to the podcast by clicking on the donation button on the QSO Today podcast website at qsotoday.com. There is a slider that you can use to adjust the amount of your donation. If you want to make your donation monthly, click on the recurring donation box. It is the recurring donations and the listener sponsorships that keep the lights burning here. Finally, you don't have to contribute anything to listen to the QSO Today podcast. You can use my Amazon affiliate link before shopping at Amazon by clicking on it on the right side of the show notes page. This will signal Amazon to send us a small percentage of what you purchase. This is the most painless way to ensure that the QSO Today project will be here next week. I want to thank everyone who has contributed and will contribute to my effort to create this oral history of amateur radio since 2014. It will eventually all be in the public domain for hams in the future to enjoy. Be sure to become a listener sponsor or make a donation today. And now we return to our QSO Today. So you're up in the Seattle area, right?
I'm 90 miles north of Seattle.
You're just below Mount Baker there?
Yeah, I can see Mount Baker from my bedroom window on a good day.
I can see Mount Baker from my father's driveway from Squim on a good day.
Oh, there you go.
It's a pretty interesting looking mountain.
It is.
It's not an active volcano, is it?
No, not at the moment.
Not at the moment.
It is considered, all of the Three Sisters are considered active volcanoes. They just happen to be dormant at the moment. They could erupt just like Mount St. Helens.
Right. You hope that you're not home.
Yep.
You're on the trip across America.
Yeah, between that and the potential for tsunamis and earthquakes, pick your emergency of choice.
Pick your poison out there on the West Coast.
Yep.
Now, I find AREDN very interesting. It seems to me that the Seattle area, the Puget Sound area, actually has quite an AREDN network up there. Is that correct?
It's starting to. The terrain is not very friendly for AREDN because in the urban areas we don't have access to some very good microwave sites, and the power levels are low, which is a gripe of mine. That we need another company like PACCOM to come into the market, to address the specific needs of amateur radio operators and have a 2.4 gigahertz hackable radio that can put out at least a couple of watts instead of 100 milliwatts, and then we could really start doing some interesting things. There are amplifiers available, but they're clunky.
So my AREDN experts have said to me that AREDN is great on the last hop. You connect the sites together with regular, not mesh networking, but regular point-to-point networking, and that the AREDN portion, the mesh portion, is used between the end users. Is that your experience, and does that work okay?
Yes, you're far better off when you engineer a microwave network, basically hard-coded. Because if you try to keep, well, I don't know, they're making strides. They came up with a concept called a supernode that keeps the network traffic to a minimum. So it's evolving fast, and which is one of the reasons why I try to keep track of it. But yes, generally an engineered microwave network works far better and more reliably. But then it's, you've got static routes that can fail. So one of the unappreciated aspects of AREDN that I try to promote is that it makes for an ideal wireless local area network. So, for example, if you show up if you and a few others show up with your Go kits at an emergency, you don't have any easy way to link between them. And AREDN is an ideal way to do that because you can flash AREDN onto a number of little small Wi-Fi access points and have your own private network, even on private frequencies. So you don't have any dependency for linking between your Go kits because a lot of MCOM, they don't like you to plug into their facilities, even the Wi-Fi. Having an little AREDN box in your Go kit plugged into your Windows PC or your Linux PC makes for an ideal way to network between each other, and they find each other, automatically.
Again, I'm thinking about the neighborhood. One of my ideas was to create something AREDN, but not in the amateur radio portion of the band, that actually connects to people's existing network, so that we put an outdoor access point on their house, and it becomes like another WAN connection. It's the WAN connection that works when the other ones fail.
Right.
We love WhatsApp in this country, so they can still WhatsApp each other and see who has eggs or who has flour or whatever.
Does Israel permit Starlink?
Not yet. No, I don't think so. I have it on my list of questions to ask you because I know that you did a field test. Would you call it a meadow test?
I called it Meadow Day because I didn't want anybody coming after me saying that, well, that wasn't amateur radio.
And it's not field day. And besides, I think the ARRL has the rights to the name.
They own the name ARRL Field Day, but there's also Winter Field Day, which has no affiliation with the ARRL.
So you did your meadow test on Starlink. First of all, tell the listeners, in case they don't know, what is Starlink?
Starlink is a new satellite-based broadband internet system, access system. It's based on a network of satellites in low Earth orbit. And what's different about Starlink as opposed to the older style of satellite internet, the older style of satellite internet used a geosynchronous satellite that stayed in one position in the sky. And that's very, very fussy. They have to protect it very well. So you have to do professional installations, et cetera. Starlink, on the other hand, was a child of the 2020s. So Starlink and SpaceX, who designed it, bet on Moore's Law, basically. The radical technology in Starlink is that these satellites are moving overhead very fast. And so to have a reasonable high bandwidth connection, you have to keep the antenna focused on the satellite as it passes overhead. But that's a non-starter if you have to do that mechanically. So we just came into the point where phased array antennas are feasible at this price point. And originally Starlink was manufacturing the ground terminals or the user terminals for something like $2,000 a piece and selling them for $500. But they've now got the cost down to the point through mass production and better technology. They don't sell the user terminal at a loss. So what happens is you put that Starlink dish in place, and if it's got a clear enough view of the sky, it figures out its azimuth and elevation. It's got both motors to point itself at a portion of the sky that it figures is optimum. And then as the satellite passes overhead, it's electronically tracking that. You don't see it move, but the elements in the antenna, the panel antenna, are tracking the satellite for transmit and receive. And it just works.
Are the satellites going over the poles? I mean, are they going north to south?
No. Oh, it's all over it's a total network. And what is now happening is the satellites right now are operating in what's called bent pipe. The majority of the satellites are operating in what's called bent pipe mode. The user and the access have to be within the same footprint of the satellite that you're using. But soon enough, the satellites, all the new satellites that are going up now have satellite to satellite links built in, but it'll be a while before there's enough of those to make a difference.
So the idea is that Starlink then is communicating one or two hops to other satellites, then back to an Earth station. So they've got a bunch of Earth stations across America, for example.
They will be doing that, yes, but they're not quite. They're not doing the satellite to satellite hops, and except in some very specific circumstances, like the satellites that are targeted to cover Alaska.
So what you're saying is you're relaying through a single satellite at a time to an Earth station, and you're being passed like a cellular telephone system. You're being from one satellite to the next satellite as the connection fails because the satellite's going out of range.
Right.
That's very clever.
Well, this dish has a pretty fast processor because it knows what the satellites are. It has basically the constellation in its database, of the dish, of my dish itself. It knows when the satellites are passing, when they're going to lose. It basically keeps orbit, and the satellite constellation constantly updates each terminal. It's just broadcasting all the time what the constellation is. So this thing is it's doing all the math, and it's just amazing.
So you actually did a trial, and what did you observe? You're in a meadow. You weren't under the trees. You were out in the open, and you were up near your house, right? So you're in the northern territories.
Yes.
Okay.
So what I observed was that with one of these modern lithium-ion battery packs, they call them solar generators, which is horribly inaccurate, but so be it. So I grabbed mine, which was a pretty small one. I grabbed a solar panel to plug into that, and I grabbed the Starlink terminal and my laptop and a table. And I went out in the middle of the yard, I plugged it all in, and it worked. It just, and I can so that to me, and my only dependency was power and the fact that there had to be an operating ground station, which there were three. There are now three in Western Washington within the footprint of any satellite any Starlink satellite that I would work through. So those have to be online. Otherwise, I had broadband internet, and the test was kind of a modern version of Field Day. Is that I made a bunch of video calls to a bunch of people using a bunch of different systems. Skype was not one of them. I didn't think to attempt Skype, but I used Facebook Messenger, I used Zoom, I used Jitsi, and just a whole bunch of conferencing system, and it was flawless. It just worked, and it worked within a few minutes of me turning it on. The dish or the user terminal figured out where it needed to be pointed. It handled it, and I had minimal connectivity, say maybe 10 megabits within a minute, and it kept bumping up as it optimized the pointing and downloaded enough information to drive the phased array better than on cold startup.
It seems to me that SpaceX, Starlink, wouldn't be building a bunch of ground stations, thousands of ground stations. But what they could do is they could leverage their consumer station and connect it to the WAN, to a fiber WAN, so that essentially a Starlink ground station could be just like the consumer terminal in reverse almost.
I've made a bit of a study of this because it also it's radio, it's space, so I've been studying this a bit, and there have been some experiments that SpaceX has done to basically do a double hop. So I'm not within range of a ground station. So say very remote area where or on the water. But there is another terminal that is within range. So I can see them, they can see the ground terminal through another. So it's possible to do a double hop through, basically a relay.
I could see that they could create a multi-WAN router on the SpaceX terminal and maybe give you a discount if you plug your fiber optic WAN into it, so that you can kind of share some bandwidth with other users who may not have that, kind of make it very democratic in terms of sharing the resource.
I'm doing an experiment with a friend of mine who's about 150 miles south of me, almost to Portland. And he's also a Starlink user, and we are pinging each other directly using IPv6. In fact, I just did a test and I logged into his home system with Secure Shell, and it was pure IPv6, and we did enough testing to know that it stayed entirely within the Starlink satellite. We were basically just doing direct; it didn't have to go through the ground station. It's starting to get really interesting.
All of a sudden, there's your AREDN links, backbone links.
Exactly, right. There were two instances of using AREDN via Starlink, and at the time that they did those, they had implemented those, they were using IPv4, which is really terrible on Starlink because they have to use what's called carrier grade network address translation. But now I think that we can dispense with this and start doing IPv4 tunneling over IPv6, because Starlink just very quietly, the middle of the year, just started assigning I think it was a /56 block of IPv6 addresses to every terminal, which is pretty disruptive when people start realizing that's available there. All of a sudden Starlink is now the most desirable. With that, Starlink kind of becomes the most desirable kind of internet connection because it's the most capable.
So this is something that I think I'm beginning to understand from our conversation right now, that maybe the listeners who have investigated Starlink or they haven't heard of Starlink, does this mean that if you're not hopping through multiple satellites, that it probably is not a good maritime mobile product yet?
No, there's cruise ships. The cruise ships are abandoning the geo satellite internet access en masse.
Like MRStat or something like that.
Yeah, they're keeping it for life safety, stuff. But for the consumer internet access on a cruise ship, if you look at Google Starlink and cruise ship, and you'll see cruise ships with like 6 Starlink terminals on the port and the starboard sides to basically aggregate all the bandwidth.
Oh, and then feed that into their internal Wi-Fi network.
It's so much saner than the geo satellite systems.
Well, I haven't been on a cruise in years, but I'm assuming that there's Wi-Fi service in all the cabins.
It's the only way you can get kids to go on a cruise these days. It's if you provide good Wi-Fi.
Most of those cabins don't have outside portals. I can imagine kids going on a cruise and never coming out of their room to look over the rail.
There was one funny early story about Starlink, that a guy who had a powerboat and liked to go powerboating on weekends, just it was like pulling teeth to get the kids to come, and because they were out of touch, and they, you can get satellite internet, through Iridium and a few others, but it's very low bandwidth and it's very expensive. As soon as they got a Starlink terminal and turned on the roaming option, the kids had no problem going out powerboating because they stayed in touch. They didn't lose. and it's a real thing for them because, they get so many messages behind. They didn't participate in the conversation, so it gets, bogged down. So Starlink on a boat, yeah.
It's there.
It works great.
You mentioned on your QRZ page that Tapper changed your life. What is Tapper, first of all, and how did it change your life?
Tapper originally stood for Tucson Amateur Packet Radio, and it was a kind of a club, kind of an engineering project that created the first widely used TNC called the TNC, what then became called the TNC1, and then the one that everybody knows about called the TNC2, Terminal Node Controller. And that basically started the big widespread packet radio activity of the 1980s and early 90s. Tapper changed my life because we were doing my wife and I sponsored the 1996 Digital Communications Conference here in the Seattle area. And I got stuck escorting the Sunday speaker to Kinko's to print his presentation, his Sunday presentation. And we got stuck behind a church program that was running. We had to sit there and wait. And he was not going to turn over his laptop to the goons at the counter. So he said, I'll wait. So we just got to talking, and he started telling me about these Part 15 devices that had become authorized in 1985 that didn't require a license. And he was starting to tell me these wonderful stories about things like, you could do, 100 kilobits per second or even megabits per second on 902 to 928, and you can do it with 1 watt and using this new technology called spread spectrum. And I knew packet radio. I just knew it cold, because I'd been living in it, as my full-time hobby, basically. And I thought, oh, you are full of it, but I didn't say that. But I happened to be lucky enough to go back to work at Boeing, and Boeing was on the internet. Boeing was a government contract. This is before the internet was, accessible to consumers. So I started looking this stuff up that he was talking about. Oh my God, he's telling the truth. He was not exaggerating about this stuff. And this blew my mind, this whole thing. So I started making as serious a study of this as I did about packet radio. And then I was a fan of a magazine called Boardwatch that covered the BBS industry. But then one month, the Boardwatch came and says, the editor said, you will notice that there are no longer any BBS articles or any BBS columnists. That's because we have fired the BBS. The future is the internet. So we need content about the internet. So if you have ideas, send them to us. And if you have any ideas about things you'd like to write about, send those to us too. So I'd been making a study of this Part 15 stuff. So I sent him a letter saying, you ought to cover this. You ought to cover this Part 15 wireless stuff because it's going to be big for ISPs. And if you can't find anybody else, I'd be willing to take a crack at it. And about a month later, I came home, and before I could open the door, my wife was flinging open the door, holding a note up to my face and says, call this guy now. Says, he's from Boardwatch magazine. And I said, oh, okay. So I talked to the editor, and the editor, Chuck, said, so I introduced myself to your wife, and your wife said, oh, yes, I know Boardwatch. Every time Boardwatch comes, I lose my husband for the entire evening. So I ended up writing a column for Boardwatch magazine, and that kind of became my life. But, my long story about how I came to quit Boeing, but I started to get more writing gigs, freelance writing gigs about this stuff, this niche that I had found myself in. I became a subject matter expert and quickly started, for a while at least, I was making more money doing freelance writing than my day job at Boeing. That's how I became a writer accidentally. And the writing sample that I sent them was from writing articles for the Tapper newsletter. Are you doing anything with LoRa? I am tracking LoRa. I've got several LoRa systems. LoRa's amazing technology, and there was this interesting kerfluffle back in the 2000s that I've written about a couple of times, where we could have had really good spread spectrum in amateur radio, but everybody was just too scared of it, and it was going to disrupt repeaters and all kinds of stuff. So we ended up with very watered down spread spectrum capabilities in amateur radio. But nobody notices that LoRa is actually spread spectrum, but everybody's using it and nobody's complaining. So, we're kind of getting backdoor spread spectrum into amateur radio through LoRa.
So you bring up a very interesting point. So a decision was made somehow not to do spread spectrum in amateur radio because of what? Because of encryption, the inability to perhaps understand all the conversations. What was the reason that the amateur radio community rejected spread spectrum?
It was because they didn't understand that because you spread a signal out, it doesn't necessarily cause interference. They were afraid that, for example, direct sequence spread spectrum, expands a signal over a wider spectrum than what a standard 12.5 kilohertz or 25 kilohertz voice channel is. The problem is that amateur radio, most of amateur radio, is locked into some old paradigms that, you just can't quite get your head around how spread spectrum would work and work better and not cause interference.
We're still doing FM repeaters the same way we did it 60 years ago.
Yes.
And now nobody uses them. We have lots of them, but they're quiet most of the time.
Right. So at the time, this was all, we were doing experiments, sanctioned experiments through a special temporary authority with the FCC. There was a very creative individual who I'm still not allowed to name, who decided to do a test of frequency hopping spread spectrum. And he decided to do that test, whether or not it would interfere or not. And he decided to do it in a very interesting way. He built a spread spectrum system for 440 megahertz, and his system hopped onto the input frequency of every major repeater in Southern California. So he was doing a data communication using spread spectrum on 440, and the hopping pattern was deliberately set to hop onto the input channel of all these repeaters, which were in very active use, especially on the weekend. So the zoo,
Right at the time.
Yeah. And because the spread spectrum dwell time was something on the order of 100 milliseconds, nobody noticed.
Or they could have said it was radar in Southern California, right? They're all used for radar.
The point is that, here was this data communications, going full bore, at I don't know what the data rate was. He never really disclosed it. He just told me this story in confidence, but it's 20 years ago now. So I think statute of limitations is kind of up, except for disclosing this person's name. And, the point of the test was that this hysteria about spread spectrum was way overblown in amateur radio. It wasn't going to hurt amateur radio. And in fact, it did. Not adopting spread spectrum kind of put us way behind the curve. But we're regaining that technological innovation curve by the interesting ways we're starting to apply software-defined radio technology in, VHF and UHF, because most people think of SDR as a technology for microwaves and, way up higher in the spectrum. And here we are doing it. We're doing interesting things on narrow channels in VHF and UHF. And even HF now, so we're clawing back some of our technological evolution or technological capabilities.
Are you doing any data communications on HF?
I am not at the moment. We just moved to our current home about 2 years ago, and it's been a struggle to get everything. Long story, but no, I'm not quite set up. But that is a project for 2024. Is to get back on HF.
And when you were on HF, what kind of digital modes were you running?
I was just basically monitoring. I wasn't really that. I was curious what was out there. I can't remember the name of the suite. I basically just tried a whole bunch of things just to see what was going on. I did whisper for a bit, that sort of stuff.
But maybe no digital voice on HF?
No, although FreeDV is definitely on my radar now. There was a very interesting experiment done on, or at least an example of a recording of a FreeDV conversation in progress, and the recording was, here was the FreeDV being decoded, and it was a perfectly understandable conversation, but if you listen to it in single sideband, you couldn't make out anything because there was such heavy interference. It was like one of the over-the-horizon radars or something like that, and FreeDV was just cutting right through it. So I believe that FreeDV ought to be a native mode, just like single sideband. It built in, especially now. Once upon a time, Flex Radio actually had a little add-in module that you could have it, and then boom, FreeDV was just another selection on your radio. But some reason they lost that capability, and I think FreeDV got a grant to try to start helping radio manufacturers add it. And there's no downside to it. It's open source technology, so there's no downside to adding it.
And you don't need a hardware codec or something like that in order to...
No.
We're way beyond hardware codecs now.
We are.
You have a newsletter on Substack called Zero Retries, and you made a reference to it earlier. I suggest to anybody that wants to read Steve on a regular basis that they also subscribe to Zero Retries on Substack. How did you start writing the Substack newsletter?
Well, first of all, I owe the name Zero Retries to my friend Bud Churchward, WB7FHC, and that was the newsletter of the Northwest Amateur Packet Radio Association, which is now defunct. But it was such a catchy name that I kind of kept it in my mind, and nobody else was using it, so I grabbed it and started using it. Zero Retries came out of just pure frustration that because I had learned to cast a wide net on information about the stuff I'm interested in. I was seeing all these really interesting things like VARA, like new packet radio, which is another technology, and a bunch of other, and AREDN. And I wasn't seeing any of this stuff discussed except in passing, what I call it, dancing bear treatment, where, it's not interesting that the bear dances well. It's interesting that the bear dances at all. And I was frustrated that the mainstream publications weren't covering any of this stuff. And finally, I just kind of had it, and I said, well, darn it, if they're not going to do it, I hardly do any worse. So I just threw it up there, and I announced it to my local group and a handful of friends and family. It started, I think the initial one went out to a total of 30 people, and it's now, I think I'm at 1080 subscribers right now, and a hell of a lot more than 1,080 subscribers.
Plus one.
Yeah, plus one. Thank you very much for subscribing, Eric. And a paid subscription. Thank you very much. That's wonderful. That helps a lot. And it was basically just trying to mention all this technological innovation that is happening now in amateur radio that isn't getting reported. And one of your questions was, what advice would I give to new hams or returning hams? My biggest advice is, don't think that what you're reading in QST or CQ is all of amateur radio. It isn't. It's like a microcosm of that. And if you're a techie and you want to be doing more interesting things, there is a much bigger world out there about the technology. Like, for example, they barely cover satellites anymore. But AMSAT is very active, and there's other AMSATs around the world that are doing great things in satellites. And AMSAT finally came on my radar. Now, instead of just flying repeaters, they're going to start putting up digital systems. So that's got me excited, and I'm going to start working towards an amateur satellite station. So Zero Retries is just my weekly snapshot of of some of the things that I found interesting. And Substack keeps giving me these warnings of, well, getting to be too big for sending an email, and then it says, this newsletter too big for email. And I've learned that to just ignore that, send it, and then I started including a web link to essentially the blog post version of Zero Retries, and just go there and read it. Don't worry about the cutoff in the email version that you saw.
I had a chance to browse it this afternoon. I think this is a good opportunity to also say that for people that want to be out on the cutting edge of all kinds of stuff, Tapper is still available and still working hard to make presentations and papers.
Yep.
The Open Research Institute that Michelle Thompson and her crew does also has very interesting cutting edge stuff. So it's really quite amazing what the hams are doing. Are you covering other projects that are kind of in those other areas as well, Steve, with your newsletter?
Yes. One of the things that I do that few other people do is I was involved for 2 years in amateur radio digital communications, ARDC. So ARDC was originally the custodian of what was called 44net, which is the 44 block of IP addresses. There's 255 of such blocks. And way back, a very, very smart guy named Hank Magnuson wandered down the hall at UCSD and talked to John Postel, who was the assigner of IP addresses. He said, amateur radio is probably going to start doing things with this new internet thing. And, we'd like a block of addresses. So he handed him a Class A address space.
How many IP4 Class A addresses are in that block?
16 million. So fast forward 30 years, amateur radio still had not used even half of them. So this organization that had formed to become the formal custodian of Net44, decided to put a quarter of them, 4 million IP addresses on at auction, and they got bought by Amazon. That's a matter of public record. ARDC isn't allowed to say it, but everybody, you can look at it in their public filings. So they made something north of $110 million from that sale, and they very conservatively invested that.
I think they're under their nonprofit. They have to give away $6 million of that a year, I think. Something like that, right? 5%?
5%. 5% of their of their total endowment every year. And they're able to do that with the proceeds, from their investments. So ARDC could keep going in perpetuity if it's managed carefully. So essentially, they are venture capital for amateur radio. They do a lot more things. They, scholarship money, a lot of university R&D that isn't necessarily amateur radio, but they also are putting money into a lot of amateur radio projects, not just research or development projects, but also just nuts and bolts projects.
Well, the Internet Archive. Last week I had Kay on. He's talking about the enormous amounts of newsletters and papers and books and all of this stuff, and the equipment that they have to be able to scan a book without destroying it. It is really, for people who actually haven't thought of going into the Internet Archive, I think he has an enormous amount of interesting material that if you're looking for a project or looking for original source material on a project, he's got it, thanks to the ARDC funding this chair.
I have personally donated something on the order of roughly 200 pounds of paper to them. And, I emptied a lot of my shelves of magazines. And what was really interesting was that a lot of the stuff that I had was from packet type. There's, for example, a magazine called Packet Radio Magazine that was published for about a year and a half. And it was intended to be a conglomeration of all the regional packet radio newsletters around the country. And it was very successful for about a year until the editor burned out. As far as I know, I'm the only one that had any physical copies of it still left. So all those went to the to
the Internet Archive.
Yeah, and now everybody can read it. It's available. And what's amazing about Internet Archive and DLARC is that they don't just scan it. They don't just do an optical scan. The first pass, if you've ever seen the systems, they use like a 10 megapixel camera.
Two of them.
Yeah, exactly. Simultaneously.
Right, because they're looking across each other.
Right. So they take TIFF images, and then they send it through their server farm, and everything gets OCR'd, it gets indexed, et cetera. So, it's better than anything I could do. Not only is the resolution better, but they OCR it. And their OCR is far superior to anything a consumer has.
Right. So now it's searchable.
Exactly. So fast forward a little bit, thinking about AI, what AI is possible now. So it's not going to be too long before somebody is going to do, something like what OpenAI has done, except for Internet Archive. Well, they won't do that for Internet Archive because of all the copyright issues. But DLARC, throw an AI at that thing, and all of a sudden you've got this, wonderful, fantastic reference. How do I make a Yagi? What was a blank? And it'll come back to you as a conversation. There's going to be an AI engine, targeted at this stuff soon.
Since I interviewed Kay for a guy with ADD, don't go there. It's a rabbit hole.
It is indeed.
And you can find anything. Because
I've contributed so much, Kay and I we're on a conversational basis. We'll just send. I said, the subject line will be fodder and just one URL. And Kay said, "Oh, good find, thanks." Added. Like I found this really good paper from one of the architects of the FCC's Part 15 decision back in 1985 that made this license exempt stuff possible, so basically enabling Wi-Fi. And it was, believe it or not, Wi-Fi was not inevitable. It was a fight. And one of the people that really didn't want Wi-Fi to happen was Motorola, because Motorola was all about licensed spectrum because they could sell stuff,
I want to take a minute to tell you about my favorite podcast, the Ham Radio Workbench Podcast, with George, KJ6VU, and now joined by Rod, VA3ON, Mike, VA3MW, Mark, N6MTS, and Vince, VE6LK. Every 2 weeks, George and company offer up a status report on the many amateur radio projects on their workbenches and explore projects on their guests' workbenches. This group is project active and prolific, covering many technical areas of amateur radio. So the next time you want a deep dive into ham radio electronic project building, or to learn about technology, tools, test equipment, construction techniques, and the rest, listen to the Ham Radio Workbench podcast, available on every podcast player and channel. Use the link in this week's show notes page to get to the Ham Radio Workbench podcast directly. And now back to my QSO. By the way, if you go into the Internet Archive, you're not going to find Motorola manuals.
No.
Even on like T-Power equipment made in the 40s, 50s, and 60s, you're not going to find service manuals or software. It's really quite interesting. I mean, they hold it so close to their vest on the one hand. On the other hand, I'm not sure you can buy a T44 manual anymore from Motorola.
Fine. It's fine. I have no... If it's their creation, they have the right to do that, but I think that's incredibly short-sighted.
You have to keep in mind that Motorola, if they would take an old system out of service, they would run over it with a steamroller in a parking lot rather than put it into the surplus market.
This is true.
To sell new radios, and I think that they still think that way.
Yeah. So one of my proudest possessions in my collection is the original Motorola Altair wireless local area network that they way back in the day. And I don't remember, I think.
Was that Part 15?
It was not. It was licensed. That Motorola went to the FCC and got a unique allocation to them, so that the only way you could use that particular chunk of spectrum is to buy the Motorola Altair radio, and I think it's still unique to them.
And do you know what spectrum it was using? It was using microwaves?
It was up in the gigahertz range, so it was fantastically expensive. And the only reason you would have used it back in the day, this was probably early 1980s, long before Part 15. And the only reason you would use something like this is if you had like a test cart that you didn't want to have to keep running cables to, so you could just put this, put a wireless link in.
Right, or a factory floor device.
Yeah, exactly. So Motorola saw the potential, but they sure as hell didn't want, the heathens, doing license exempt stuff. So they fought it, but they lost. Thank goodness.
Before we go, I saw that you announced the wedding of your daughter and that your daughter's a ham.
Mm-hmm.
Do you have other children, and are they also hams?
No, our daughter has us outnumbered 1-2. She was an only child.
How did you make her a ham? Do you have some secret sauce that convinced the younger generation that they should be amateur radio operators? This
is, to me, a very funny story. It's a matter of public record if anybody bothers to connect the dots, so I might as well disclose this. So, as I said, I was involved with amateur radio digital communications as a volunteer. And as they grew their capabilities, they needed more and more staff to, administer these grants and grow the infrastructure. So eventually they needed essentially an office manager position, and they put it out for, open applications. And I pointed it out. Meredith happened to be relocating from Boston to Portland at the time. And so she had quit her job in Boston and hadn't had anything lined up in Portland. I said, you might want to look at this one because it's 100% remote. It's amateur radio. I'm sure they're paying pretty well. And that's all I did. I pointed her at the job opening, and she got the job. And she had said, and because ARDC is so involved in amateur radio, she said, well, and then she told me, Dad, I've always wanted to get my ham license. I just never quite was ready to do it, but this is a perfect reason to do it. And within like 2 months of her starting the job at ARDC, she got her license, KK7BKI. And, I never tried to push her because I had seen that approach with other hams kids, and it didn't go well. They just, basically the ham parents, needled the family members until they finally acquiesced, and then they, said, okay, fine, get off my back. It's, I got my license. I don't have to use it, but I got it. So I didn't want to do it with Meredith, and Meredith is now, she's interested, and we're going to build a couple of projects over the winter when I pop down, and we're going to do some soldering projects together. In fact, we're going to put together a project called DigiPi, which will be her first digital system.
Well, that sounds pretty cool.
Yeah, it's going to be fun. And I'm also going to get her, I'm going to try to get her plugged into the AREDN network. She lives in a high-rise apartment in downtown Portland. I suspect she can get some really good, I've got to figure out which is the ideal AREDN radio for her to plug into their mesh network in Portland, in the Metro Portland area.
That could be hidden in a plastic cactus on her porch.
Exactly.
So that it doesn't cause anybody to get excited.
Well, one of the funnier things I've seen lately is that people are now repurposing the dish networks, satellite dishes, not only for AREDN and HamWAN, that's another microwave network, but they're also now they're turning them into slot VHF UHF antennas. You very carefully carve out
a horizontal slot. I'll put a link to John Portune's article in making a VHF UHF slot antenna out of your satellite dish.
You can't tell that it's not, doing its original intended, and those are completely legal. And, as soon as you waive the FCC at the apartment management, they'll say, okay, fine, you can have it.
Steve, it was really a pleasure to meet you and a pleasure to talk to you. I want to thank you for joining me on QSO Today. Anybody that wants to reach you, the best way to do that is how?
My email address is steve.stroh@gmail.com. You'll see me all over the place at www.zeroretries. That's spell it out, zeroretries.org.
And hopefully, if they find you, they'll find your newsletter, and I'm looking forward to reading mine.
Substack is just happens to be a good publishing platform. It had these magic ingredients that basically Substack lets you create a newsletter, send one email, and the subscribers take care of themselves. They self-manage, they pay. Substack takes care of all of the payments. And by the way, I need to emphasize this. Zero Retries is a publication that is free to subscribe to. You do not need to pay for it. If you want to pay for it to help support what I'm doing there, I welcome that. Thank you very much. But it's not required, and I try very hard to keep it open for anybody that wants to read it at any time. The archives are free. There's no paywall at all. I detest paywalls, especially in amateur radio, at least. And so it's free as in beer. There are a few very minor benefits to being a paid subscriber, but I really wanted, and I happened to use Substack because it was the most mature newsletter publishing system at the time. There are others now, and future newsletters that won't be about amateur radio, I'll be using a different platform for reasons that aren't germane to this conversation.
Substack also has lots and lots of other writers as well. So as a platform, it seems to me that it has its own app. If you find other writers, if you like to read.
I am just amazed that I am on the same platform as, I can't remember her name now, but she writes Letters from an American, and so many, and Cynicism and other very, very good. It's the new Time magazine. It's just it has enabled people to do things that you didn't used to be able to do. It lets you write and it gets out of your way. It's a great system. They zeroed in on exactly what I needed at the time.
You're not having to do the hosting. You're not.
Yep.
It's my understanding that the writing tool is also very good. It's like a blogging system.
It is a blogging system with kind of an email system, very well integrated. So once I send out the newsletter, it's available on a web page and complete with an RSS feed. So I've got a lot of subscribers or a lot of readers that are not on my email list. So I don't know how big the total audience of Zero Retries is. I don't have a way to know, because there's an awful lot of people that just set it up as an RSS feed for them, and they see it simultaneously as the email goes up. They don't need to subscribe.
Yeah, I don't either. It's a very interesting thing. Is I'm writing a blog right now, and it uses an RSS feed to trigger GetResponse, which sends out messages to people. But there's a lot of hosting and stuff that goes on in order for me to notify people I'm writing stuff. And so Substack sounds, if I want to simplify my life at some point, it sounds like it might be the right way to do it.
It's not overstating it to say that if it hadn't been for Substack and now equivalent tools, there's one called Ghost that's pretty good. If there hadn't been that tool, I would not have done Zero Retries. The overhead of integrating all of the pieces for email subscriptions and collecting payments and archiving and, hosting and all that stuff, just too much. It would have gotten in the way. I would have spent more time administering it than writing it. But so as it is, basically my work in administering and doing Zero Retries is basically sitting down to write the newsletter, and all the other stuff happens behind the scenes. Substack takes a chunk of each paid subscription, which I'm happy to let them do. It's because they're earning their money.
As a guy that has all of these infrastructures with some DigitalOcean servers that kind of manages all this stuff going on in between, I can tell you that in my retirement, I'm looking forward to making things a little bit more simple. So you've convinced me. Steve, again, what a pleasure. Thank you so much for agreeing to come on QSO today. Thanks to Kay for introducing us. And I appreciate so much that you came on, and I wish you 73 and hope to work you on one of your digital modes.
Thank you. Well, and I kind of paid it forward from Kay with the recommendation of the individual that, I sent to you, who's a brand new ham and very geeky digital guy. And I hope you catch him. I hope you're able to talk to him, because you're going to hear a really fascinating story about his journey.
Well, I have to tell you, and the listeners may know this because I've said this before, at the very beginning, I would interview the long-time hams, the hams that have been, and I still kind of have a preference because they tend to be, in my age group, and so therefore it seems like there's longer stories. On the one hand, some of the new hams that I've interviewed recently, and I'm talking only within the last few years, are doing things in ham radio that none of us would have ever thought of in our lives. But it's still ham radio, and it's still like amazingly interesting, and I keep thinking, why didn't I think of that? What we need is new blood that actually comes in with a whole different look at the way that we look at amateur radio in order to kind of launch it into the next century.
On that note, there was a conference that just concluded a couple of weeks ago called GNU Radio Conference, which is software-defined radio. They had a VE session at the GNU Radio Conference to get new techs licensed. And, imagine people that are, comfortable writing software-defined radio code becoming hams. And that's exactly what we need to be doing. And unfortunately, you don't hear about that kind of stuff from the conventional powers that be in amateur radio.
But we're going to hear about it on your Substack.
You already did. You just got to catch up, Eric.
I do. I have a lot of reading to do.
Well, thank you very much. I'm a longtime fan of your podcast. And like I said there before you started recording, I have a very long list of folks, podcasts to listen to from what I term Zero Retries interesting, which is a pretty small subset, but it's still like dozens of interviews that I want to hear. And man, that one that when I listened to your interview of Wayne Green, boy, that was stellar. Good job, man.
It wasn't Wayne Green.
Oh,
it was Art Bell, probably, right?
Yes, Art. Boy, there was actually a conversation archived between Art Bell and Wayne Green.
Can I tell you something? Art was a real gentleman. I didn't think when I sent that invitation that he would actually reply, but he replied. But not only did he reply, he was such a charming guest. And that was the kind of person that he was. The fact that he's gone is, we're all diminished slightly for that. That was one of the highlights of my ham radio career, was to talk to Art. But thank you for remembering that.
I applaud you as somebody who's, trying to help amateur radio's legacy about, putting all this obscure stuff that I've acquired into the Internet Archive. And you're doing your part of getting, fantastic job on your trying to preserve these stories about that you're doing. It's just fantastic. And
oh, you're making me blush, and probably I'm going to edit this out.
Eric, you're doing a fantastic job, and I when I was thrilled when you came back. I was thinking, oh, he's not going to want to talk to me, Kay's got a big project here. I've got this little newsletter, but it was so cool when you said, "Oh yes, let's talk." It was quite a thrill.
One of the things that you learn when you do this is episode 477. When you've done this many interviews, you actually learn to just like to talk to people, and I think that's what we're doing more now. Is I'm less structured than I was before, and the conversations go to places that I wouldn't have thought. Last week I was talking to Kay about Atari 800.
Mm-hmm.
I don't know anything about Atari, but I remember the time, and I remember that whole amazing era from the Altair through the MSI, when everybody was trying to define what should a computer look like. Is it going to be an office computer, kind of like the IBM at the time had their small mainframes that they were still putting out the System 38s, and they were maybe just getting to the small servers that they were putting into people's offices. But I think that what was so amazing about that time was just everybody's noodling this idea of what would these things look like. And I think we now know what they look like, but I think the same thing is happening in amateur radio. And I think, Steve, that the stuff that you're doing and the stuff that Tapper's doing and the ARDC being involved in funding some of these wild, harebrained ideas is bringing back the same kind of wonder that we had in the computer age.
I agree. That's the driving factor for me, is the sense of wonder about all of this technology. And what's really fantastic and what's underappreciated about amateur radio in this era is that you can, we can't live without wireless technology anymore. It's just an essential fact of modern life. And there's an awful lot of university graduates that never actually get hands-on other than a little bit of laboratory experimentation, maybe using a Part 15 device. And amateur radio is literally a license to experiment and learn about this stuff hands-on. Boy, you get when you start playing with antennas, you get a visceral sense of how RF actually works, and why things fall down when they do. It's just an amazing, ability to learn, and that's the best part about amateur. I think it's the essential element of amateur radio in the 2020s and beyond. Is it's a chance to learn and experiment.
What's interesting is that when you talk to people about, I'm doing a radio merit badge for Boy Scout Troop.
Oh, excellent.
I've got like 15 young guys, and when you say, your smartphone is a radio, it's like this, what? What are you talking about?
Exactly.
And I hand them an AM/FM shortwave portable that runs on AA batteries. And they go, what's this? What's this? And they turn it on and they hear the noise and they go, wow, what is this? We took this for granted growing up, that there were signals in the air, but their brains light on fire. I've written in my blog about my 9-year-old protege that comes to me every week now. He is just overwhelmed with just the whole idea. It causes him to kind of do what we're doing right now in terms of thinking about what could we do with Starlink and what could we do with GNU radio or something like that. It's a great time to be in radio, Steve. It's a great time to be showing people what it is, even though they're all carrying radios or using their wireless headsets or all this stuff, and they have no idea that in fact that's what it is. And maybe we were involved at some point along the way in helping that come along.
One of the fantastic things that ARDC is doing in their grants is they are funding new educational outreach in various ways at schools. There's a whole independent program called MORE. AMSAT, they funded ARIS, amateur radio on the International Space Station, to build up a curriculum, a STEM curriculum for teaching radio technology as part of the ARIS activities. They're paying for new stations at schools. If you run down the list of the grants that they've allocated already, it's just amazing, the stuff. And with that funding engine, amateur radio, I had kind of despaired for amateur radio, the future of amateur radio, but ARDC is now enabling a future for amateur radio because we can start regaining our relevance with these sorts of things. And I'm sorry, I could talk to you all day, Eric.
I could too. I'm having so much fun. I was so thrilled to speak with you, Steve. I look forward to speaking to you again. I wish you only nothing but success with your newsletter. 73, Eric.
Thank you for the vote of confidence in becoming a paid subscriber. That was a very pleasant surprise when I woke up this morning. Thank you.
Oh, it's my pleasure. Take care now.
That concludes this episode of QSO Today. I hope that you enjoyed this QSO with Steve. Please be sure to check out the show notes that include links and information about the topics that we discussed. Go to www.qsotoday.com and put in N8GNJ in the search box at the top of the page.
You may notice that some of the episodes are transcribed into written text. If you'd like to sponsor this or any of the episodes into written text, please contact me. Support the QSO Today podcast by first joining the QSO Today email list by pressing on the subscribe buttons on the show notes page. I will not spam you or share your email address with anyone. Become a listener sponsor monthly or annually by clicking on the sponsor buttons on the show notes pages. Your value for value support is recognized on the QSO Today podcast and in the weekly show notes. Use our Amazon link when you shop on Amazon. Clicking on this link before you enter Amazon will allow Amazon to pay us a small commission on what you purchase. This is a very painless way to support the QSO Today podcast. QSO Today is syndicated on every podcast platform, including Spotify and the iTunes Store. Until next time, this is Eric for Z1UG 73. The QSO Today podcast is a product of KEG Media Inc., who is solely responsible for its content.